Hello, Mr. Fake here. I just wanted to go through a couple examples on how to construct these ray diagrams. Now, before we get started, I know you might be nervous. We haven't really done this before, and this is not the ideal set of circumstances to be learning this. It's always nice to be able to touch base in the class about what we're doing. But take your time. Just take your time. Be careful with your ray diagrams, and just go with it. Now, we're not looking for perfection here. As we move forward with mirrors and lenses, understanding how the rules for these rays are important. And what we're really looking for is just that you're getting the idea of how these rays behave. So if your images aren't quite perfect, that's okay. You're going to see that mine probably aren't either. So I want to start with a plane mirror or a flat mirror. And I have this candle here in front of the mirror. The image from a plane mirror is very easy to predict and to understand, but ironically, the ray diagram is the trickier to draw with these flat mirrors than it is with the spherical mirrors. For the spherical mirrors, I just have 3 rules to worry about. For the flat mirrors, there are no rules. You just need to follow the law of reflection. So on this candle, I'm going to choose 2 spots that I want to figure out where the image will be. I'm going to look at the top of the candle, and I'm going to look at the bottom of the candle. And I can send rays in any direction from these 2 points, so I just want to choose a simple one at first. Now I'm going to use my ruler, and I'm going to send a ray straight to the mirror, along basically the normal line. Now, if you don't have a ruler at home, you can use a folded piece of paper as a straight edge, and that'd be fine. I'll do that for the bottom point just to show you that doesn't really make a difference. So there's one ray going to the mirror. Now I need another incident ray going to the mirror. I can go again. This is where students get a little frustrated. They go, how do I know where to send it? And the answer is send it wherever you want. You just need to go from that point, and you need to hit the mirror somewhere. All right, those are my 2 instant rays. Now what I'd like to do is do the reflected rays. So to figure out the reflection, I need my normal line. Now for this ray, it's easy. It's on the normal line, so it has no angle. It strikes the mirror head on, so it's going to reflect straight back. And I like to mark my reflection with an R so I can keep my reflections, identify my reflections compared to the incident light, because I need to know the reflections for the image. Now, for this top ray, in order to figure out how it reflects, I need to draw a normal line. So I'm going to do my best to construct a perpendicular line to where this ray strikes the mirror. Now, there's my normal line. Now, how careful I am measuring the angle is going to determine how good my image will be. Now, if we were in school, we'd probably use one of these guys, a protractor, to get those angle measurements as precise as possible. But you probably don't have one of these, so forget about it. So we're just going to eyeball those angles as careful as we can be. So I like to mark them to make it a little bit easier to judge. Here's my angle of incidence, or my theta I. I need to make the same angle above, or as close to it as I can. That's my theta R. Now, I'm just eyeballing it. So I'm hoping that I'm close, but, I'm not the greatest artist either. So this is might be off a little bit, but we'll see when we do the final image. And I'm going to mark that reflection with an R as well. All right, so I have 2 reflections from the top. I'm going to do now 2 reflections from the bottom of the candle. And I'll use this piece of paper as a straight edge. Again, I'm going to make my best judgment about going straight to the mirror. And then I can now send light any direction I want as long as it strikes the mirror. I'll go downwards. All right, now I have my 2 incident light from the bottom. I need to make my reflections. Again, I sent this ray right from the normal line, so it's going to reflect straight back. And again, for where I hit the mirror here, I need to construct a normal. And I need to make as careful as I can about getting this angle and make sure it's the same as the reflection angle. I also need to make sure that I get as close to where that incident light hit the mirror as possible. All right, so for each point of on the candle, I have 2 reflections, and I note that these reflections don't cross. And so now, if they don't cross on the real side, I need to project these reflections backwards to see where the image will form on the virtual side. Now, you want to be careful to make sure you're dotting back your reflections and not the incident light, which is why I like to mark those reflections with an R. I'm working around the document camera, so it's a little bit awkward. All right, so these 2 light rays started from the top of the candle, the reflection. So these reflections, this should be where the top of my image is of the candle. So I just need to do the same reflections and see where they cross. Now again, this light came from the bottom of the candle, so this should be the bottom of my candle image. Now, right away, you see that I'm not that good an artist. If I did this perfectly correct, this angle and this bottom of the candle should be right under the top of the candle. It looks like actually that top angle right there was a little bit off. So you can see that this angle is a little bit small. If I made this angle bigger, that point would be closer over to the bottom of the candle. Again, we're not looking for perfection here. We just want you to go through the process of drawing the incident and reflected light and then project them backwards. So in my case, the candle is not going to be too good. I'll have the flame there and I'll have it over here. But it doesn't quite match up what I see. But again, that's because this ray is probably off. But you don't need to redo it. Just be careful in the first time, and we're just looking for the process. Now, probably the hardest thing about this exercise is you need to get this submitted on the computer. So you're going to need to take your camera and your phone and take a picture, and then either transfer that video to your computer and upload it that way through the website, or you can actually just do it from your phone. You can log into the website from your phone, either through the web browser on your phone, or you can download the Moodle app, which is kind of handy, from the Apple Store or the Google Play Store. All right, so that's how you do a plane mirror. I want to do now one of the concave mirror examples. And these are actually easier because we have our 3 rules. You should have them written out in front of you as a reference. I'll try to write the rules down as we go. So here, this gray arrow here is my object. It's on the center of curvature. Here's my focal point, which is halfway between the mirror and the center of curvature. And here is a spherical concave mirror. So I need to draw my ray diagrams, and I'm going to first use rule number 1, which says that any incident ray parallel to the principal axis reflects through the focal point. So again, I'm going to try to be as careful as possible and draw my ray to the mirror parallel. There is my incident light, and it needs to reflect through the focal point. And I'll mark that reflection with an R again. Now I need another incident ray from the top of the arrow to see where the image will be. I'm going to use rule number 2 now. That an incident ray through the focal point, or from, that reflects parallel to the principal axis. So I line up back on the top of the object, and I line up on my focal point, and I send light to my mirror. It strikes the mirror. It reflects back from the mirror parallel. I mark that reflection with an R. Now, since this is the top, light started from the top of the object, this must be the top of the image. Again, on the bottom, since the light's coming from the center, this is rule number 3. Any light that comes from the center of the curvature will bounce back across the center. So I know the bottom of the object, of the image rather, must be on this principal axis. So my image should be here. Now this is pretty good. Again, I'm eyeballing it, so the angles aren't precise. Later when we do it mathematically with equations, we'll see that if I'm exactly on the center for the object, the image will be directly below it and the same size. But this is pretty good for just a quick sketch with a pencil. The image is on the real side of the mirror, so this is a real image. And again, real means that if I put a piece of paper where this image is, I'd be able to shine it onto a piece of paper. And you know, I would demonstrate that in the classroom if we were there. It's hard to do over the video camera. Here's another tip, though. From a single mirror or a single lens, real images are always inverted. So if you're dealing with just a single mirror or later on a single lens, if your image is coming up inverted, it's a real image. That's a quick little tip to identify it. And that's all there is to it. Again, we're looking at you following the rules. Take it one step at a time. Take a picture of your work. Upload it to the website. Notice I only had to use 2 rules because I only need to have 2 rays cross in order to figure out the image. So I want to let's shift over a little bit, and I'll just show you how to apply the 3rd rule if you had to. Here I have the object between the center and the focal point. So let's say I wanted to send a ray from the center. Now I'm not going to send it backwards away from the mirror. So what I'm going to do is do the trick we did on the presentation. I'm going to line up the top of my object with the center and send light as if it was coming from the direction of the center. Notice I don't draw the line behind here. The light is coming from the object and striking the mirror. It's not here. This is just on the video. The presentation was just a reference line. You can dot it if you want, but I like to restrict dotted lines to projections behind the mirror. It just makes it a little bit easier to follow your diagram. But it wouldn't matter anyways, because since I went from the center, the rule is it's going to go bounce. It's going to reflect back through the center. And here's my reflection. And again, if I send light parallel to the principal axis, it will reflect back through the focal point. You'll actually see the reflections cross down here. So my image would be somewhere around here. Again, that's going to be a real image, but where this one was about the same size as the object, this one, of course, is larger. So there you go. All right, so just practice this. Take your time. Use a pencil. Again, if you can't print out the worksheet, that's okay. Just make a careful sketch on notebook paper. We're all just going to try to work with what we have here. Next week, we'll continue on with spherical mirrors, and then we'll start transitioning to how to do it with equations. But it's always good to start out with the diagramming the vectors first to understand, so we get a better feel for if the equations are telling us the right things. All right, talk to you later. Bye.